Close your eyes for just a moment. Go ahead, I'll wait. Now open them. In that brief darkness, your brain was already preparing for something extraordinary. Because tonight, when you finally surrender to sleep, your mind will do something impossible. It will create entire worlds from nothing. You'll talk to people who don't exist, visit places that have never been built, experience emotions about events that never happened, and somehow, in the moment, it will all feel completely real. Every single night of your life, you become the unwitting star of a movie you didn't write, directed by a version of yourself you'll never meet, in a theater that exists only in your skull. You might find yourself flying over cities, having deep conversations with strangers who feel like old friends, or inexplicably sitting in a bathtub filled with cheese while your high school math teacher explains quantum physics. And in the dream, none of this will seem strange. What if I told you that scientists can now watch your dreams happening in real time? That they can guess what you're seeing while you sleep with surprising accuracy, that your dog is probably dreaming about you right now, running through dream versions of your neighborhood, and that somewhere in your brain there's a system so precisely calibrated that it paralyzes your body every night to stop you from acting out these impossible adventures. Here's something even more mind-bending. Right now, as you read this, your brain is already collecting material for tonight's dreams. That conversation you had this morning, the song stuck in your head, the slightly weird thing your coworker said at lunch, all of it is being filed away, ready to be remixed, reimagined, and possibly transformed into something completely unrecognizable by the time you're asleep. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or just trying to wind down after being human for too long, you've found the right place. Tonight, we're diving deep into one of the last great mysteries of human existence, dreams and the sleeping brain. This isn't just about why we dream or what dreams mean. It's about understanding one of the most remarkable things your brain does, creating vivid, emotionally rich experiences from pure imagination, all while you're completely unconscious. It's about the hidden architecture of sleep, the brain regions that light up like a city at night, and the evolutionary purposes that might explain why we spend roughly a third of our lives in this strange, vulnerable state. Fair warning, this might be so interesting it keeps you awake. But if it does, at least you'll learn why that's happening, which feels like a fair trade. And honestly, if you're going to lie awake at night, you might as well understand what your brain is supposed to be doing instead. Take a deep breath, settle in. Let's begin our journey into the theater of the dreaming mind. What exactly is a dream? It sounds like the simplest question, doesn't it? But defining a dream is like trying to hug a cloud. You can get your arms around it, but nothing solid stays in your grasp. At its core, a dream is a series of thoughts, images, emotions, and sensations your mind creates while you sleep. It's the original streaming service beamed straight from your brain's production studio, sometimes dramatic, occasionally terrifying, and more often than not, completely nonsensical. Yet despite their surreal qualities, dreams feel real while they're happening. You might fly, fall, argue with a walrus in a tuxedo, or show up late to high school exams despite having graduated 10 years ago. And during the dream, you're convinced it all makes perfect sense. Your dream self doesn't pause to question why you're taking a calculus test while riding a bicycle through your grandmother's kitchen. It simply accepts this as reality. This is one of the most remarkable aspects of dreaming, the suspension of critical thinking. The part of your brain that normally says, "Wait, this doesn't make sense," is essentially taking a nap, which means your dream self will readily accept that you can breathe underwater, that your childhood home has somehow gained 17 new rooms, or that your boss is now a sentient potato offering career advice. The ancient mystery for most of human history, dreams were considered messages from the gods. Ancient Mesopotamians built entire systems around dream interpretation. They believed dreams were windows into the divine will, prophecies about the future, or warnings about impending disasters. If you dreamed of water, it might signify purification or danger. A dream about teeth falling out? Probably not good news for your family. Egyptians took this even further. They had professional dream interpreters like sleep time oracles with scrolls for every symbol. Dream of a cat? There was a scroll for that. A flying crocodile? Definitely a scroll for that. They even built dream temples where people could go to receive healing dreams from the gods. Then came ancient Greece, where philosophers like Aristotle made a revolutionary suggestion. Dreams might actually come from within the dreamer, from the body and mind rather than divine sources. He proposed that dreams were caused by bodily sensations and movements of the blood during sleep. While he was wrong about the specifics, he was the first to seriously suggest that dreams weren't mystical messages but natural phenomena that could be studied and understood. Still, the idea that dreams had special meaning persisted for centuries. Medieval Christians believed dreams could be messages from God or temptations from the devil. Islamic scholars developed sophisticated systems for interpreting dreams based on the Quran and Hadith. Indigenous cultures around the world developed their own rich traditions of dream interpretation and dream work. Fast forward to the early 20th century, and Sigmund Freud made dreams fashionable again. He believed dreams were the royal road to the unconscious, revealing hidden desires, fears, and forbidden wishes. According to Freud, dreams were wish fulfillment, often containing repressed sexual or aggressive content disguised in symbolic form. A cigar wasn't just a cigar in Freudian dream analysis, it was probably something else entirely. It was all very dramatic and probably not entirely accurate, but it did inspire countless armchair analyses and at least a few awkward conversations. Freud's ideas dominated psychology for decades, despite having very little scientific evidence to support them. Carl Jung, Freud's former protege and eventual rival, took a different route. He believed dreams connected us to a shared human experience, the collective unconscious, where symbols carry deep archetypal meaning transcending individual life stories. In Jung's view, dreams weren't just about personal experiences, but tapped into universal human symbols and myths that appear across cultures: the hero's journey, the wise old man, the mother figure, the shadow self. Enter modern science. But here's where science taps philosophy on the shoulder and says, "Mind if I take a look?" Modern neuroscience takes a more grounded approach. Instead of assuming your dreams hide deep secrets about your mother, sorry, Freud, researchers now study the brain's activity during sleep, using sophisticated technology like EEG, fMRI, and PET scans. And what they found is extraordinary. Dreams are closely linked to specific sleep stages, most notably REM sleep. REM stands for rapid eye movement, and during this stage, your brain is surprisingly active, sometimes almost as active as when you're awake. In fact, if you looked at a brain scan of someone in REM sleep, you might think they were awake and engaged in complex problem solving. Your eyes dart around beneath your eyelids, hence the name rapid eye movement. Your heart rate rises slightly, your breathing becomes irregular, and your body becomes temporarily paralyzed, which is probably for the best, or else you'd be acting out your dreams on your pillow. Imagine sleepwalking through every dream you have. You'd wake up exhausted, possibly injured, and with a lot of explaining to do. Dreams can occur in other stages too, what we call non-REM sleep, but these tend to be more abstract, less vivid, generally more meh. They're often described as more thought-like than dream-like, vague impressions, fleeting images, disconnected thoughts rather than full narratives. The wild, cinematic dreams with talking giraffes and dramatic plot twists, those are usually courtesy of REM. The mystery deepens. Here's where it gets tricky. Scientists still don't entirely agree on why we dream. Is it purely biological? Is your brain defragmenting itself like an old hard drive, sorting memories and consolidating learning? Or is it still whispering symbolic messages in a language we haven't quite cracked? Or is it something else entirely? A side effect of brain activity with no particular purpose at all? The truth is probably some combination of all these theories. Dreams likely serve multiple functions simultaneously, which makes them both fascinating and frustratingly difficult to study. Not everyone dreams the same way, and some people claim not to dream at all, though more often it's just a matter of not remembering them. Dreams are notoriously slippery when it comes to memory. You might wake up with perfect recollection of a dream involving a space opera starring your pet hamster, only for it to evaporate like mist by the time you finish brushing your teeth. There's actually a neurological reason for this memory slipperiness. The brain doesn't store dream memories the way it stores other memories. The regions responsible for encoding memories, like the hippocampus, are not as active during REM sleep, which is probably why our dream memories fade faster than a Snapchat story. It's as if your brain decided this doesn't need to be permanently filed. It was just for entertainment purposes. Still, some dreams do stick with us. The vivid ones, the scary ones, the emotionally powerful ones burn brighter in the mental archive. These are often the dreams that feel significant, the ones that stay with you throughout the day, coloring your mood and making you wonder what they might mean. Daily life meets dream life. Here's a fascinating twist. Researchers have found that dream content often reflects what's happening in your waking life. It's called the continuity hypothesis, the idea that your daily experiences, emotions, and even media consumption sneak into your dreams. Your brain doesn't create dreams from nothing. It uses the raw materials of your waking life, places you've been, faces you've seen, emotions you've felt, problems you're trying to solve. It's like a collage artist working with clippings from your life, but drunk and with no sense of narrative coherence. So if you binge-watched 5 detective episodes, argued with your boss, and ate spicy noodles before bed, don't be surprised if your dreams involve a chili-fueled crime scene where your boss is the suspect and the murder weapon is a giant noodle. Your brain is simply working with what you gave it. But dreams aren't just daily leftovers. They can be wildly creative, combining elements in ways you'd never consciously imagine. Many artists, musicians, and inventors claim dreams inspired their work. Paul McCartney famously heard the melody for Yesterday in a dream and immediately rushed to write it down before forgetting it. Mary Shelley's Frankenstein was dream-born. She dreamed the central scene of the creature coming to life. Dmitri Mendeleev said the periodic table came to him in a vision during sleep, with the elements arranging themselves in perfect order. The chemist Auguste Kekulé discovered the ring structure of benzene after dreaming of a snake eating its own tail. Elias Howe perfected the sewing machine after dreaming of being captured by cannibals whose spears had holes in the tips, which inspired the crucial design of putting the hole at the point of the needle rather than at the base. While dreams may be strange, they're also a space where the mind lets loose. Without the rules of logic or physics, your brain can experiment, rehearse, fantasize, and reflect, all without you lifting a finger. It's like going to the movies, except the scriptwriter, director, set designer, and cast are all you, and none of them know what they're doing. There's no budget, no script supervisor, and certainly no fact checker. But that's part of the magic. Dreams are messy, mysterious, and profoundly human. They're quiet proof that even while we rest, the mind is anything but still. Your brain is constantly active, constantly creating, constantly trying to make sense of the avalanche of information it processes every single day. So the next time you drift off, remember, you're about to star in your very own midnight adventure. Improvised, unfiltered, and possibly featuring a talking penguin. And while you might not remember it in the morning, your brain will have done something remarkable, created an entire experiential reality from pure neural activity. That's not just biology, that's art. We often think of sleep as one long, uninterrupted snooze, like pressing pause on consciousness for 8 hours. But under the hood, sleep is surprisingly complex, a well orchestrated cycle. Scientists call it sleep architecture, which makes it sound impressive and slightly expensive. The sleep cycle, sleep divides into two major categories: REM sleep and non-REM sleep. Non-REM sleep has three stages: N1, N2, and N3, which sound like Star Wars droids but are actually different depths of unconsciousness. These stages cycle roughly every 90 minutes, like a looped playlist your brain keeps replaying throughout the night. Stage N1, the gentle descent. This is the lightest stage, when you're just beginning to drift off. You're still aware of the world around you, kind of, but your brain has started shifting gears. You might feel your limbs twitch or suddenly jerk awake from a sensation of falling. Don't worry, that's not your soul leaving your body, just your nervous system glitching on the way down. Brain waves slow from active beta and alpha waves into slower theta waves. It's the twilight zone between waking and dreaming. If someone wakes you during N1, you might insist you weren't asleep at all, which is technically true and also slightly delusional. Stage N2, light sleep. Now you're sinking deeper. Body temperature drops, heartbeat slows, eye movements stop. This is where your brain gets more serious about sleep. You're not quite dreaming yet, but you're definitely not taking calls. The brain starts showing little bursts of electrical activity called sleep spindles and K-complexes. These names sound like indie rock bands, but they're actually protective mechanisms that help keep you asleep by blocking external stimuli. That car horn outside? Your brain just gave it a gentle shush with a well-timed spindle. You'll spend about half your night in this stage. It's the workhorse of sleep. Not flashy, but incredibly important. Stage N3, deep sleep, also known as slow wave sleep, or delta sleep. This is the big one, the restorative phase, the deep clean cycle on your brain's dishwasher. Your brain produces slow delta waves, huge lumbering pulses of activity that wash through your cortex like waves lapping a beach. This is when your body repairs tissues, builds bone and muscle, and strengthens the immune system. If you're a growing child, your body releases growth hormone here. Adults don't get taller, unfortunately, but we still get the benefits of this cellular spring clean. It's very difficult to wake someone from deep sleep. If you do, they'll likely be groggy, disoriented, and a little annoyed, like someone yanked from a very warm bath by a foghorn. Dreaming can happen in this stage, but it's usually not vivid, more like static-laced flashes of thought or vague impressions. The real movie magic happens next. REM sleep. The Dream Factory. Welcome to REM sleep. This is the mysterious realm where the brain lights up, your muscles go limp, and your eyes dart around beneath closed lids as if watching an invisible tennis match. REM is where the bulk of your most vivid and bizarre dreams happen. It's the brain's sandbox, a place for strange stories, illogical logic, and the occasional celebrity cameo. But REM isn't just entertaining. It plays a vital role in memory consolidation, emotional processing, and creativity. Some researchers believe REM sleep helps you sort through the emotional messiness of the day, like sweeping up confetti after a wild parade. Here's the strange part. During REM, your brain is incredibly active, sometimes just as active as when you're awake, but your body is completely still. You experience temporary paralysis called REMatonia, which prevents you from acting out your dreams. Your brain says, let's imagine you're being chased by a giant jelly bean, and your body responds, cool, I'll just lie here completely motionless. Each REM phase gets longer as the night progresses. The first cycle might be only 10 minutes, but by morning it can stretch to an hour. That's why dreams feel longer, weirder, and more vivid as the night goes on. The full cycle, putting it together, your brain starts in light sleep, N1 drifts into N2, sinks into N3 for heavy-duty repair work, then pops into REM for late-night theater. Then it starts over. This full cycle lasts about 90 minutes, repeating 4 to 6 times per night. But proportions shift. Early in the night, you get more deep sleep. Later, more REM. It's as if your brain schedules maintenance first, then settles in for entertainment. Why it matters when sleep architecture is disrupted by stress, caffeine, blue light, or late-night existential crises, it messes with everything. You might not reach deep sleep, or your REM might be cut short. The result? You wake feeling groggy, unrefreshed, and mildly betrayed by your own biology. Sleep isn't just one thing. It's a carefully balanced rhythm, with each stage doing its part. Understanding this rhythm can help you get better rest. You don't need to become a sleep technician, but respecting the architecture, keeping a steady sleep schedule, reducing light before bed, avoiding caffeine too late, helps your brain do what it does best, quietly, efficiently, and without waking you up to brag about it. Why do we dream? It's a question that's haunted philosophers, scientists, and sleepy poets for centuries. Despite all our fancy technology and late-night pondering, the truth is we still don't know for sure. Dreams remain one of the last truly mysterious frontiers of human experience. The memory consolidation theory. Many scientists believe dreams are linked to memory. During the day, your brain collects an avalanche of information. Faces, facts, conversations, disappointments, lunch menus, stray TikTok jingles. At night, it needs to sort through all that mental clutter. According to the memory consolidation theory, dreams are part of this cleanup job, a kind of mental filing system. Your brain decides what to keep, what to toss, and what to send to that mysterious place where lost socks and forgotten passwords go. Interestingly, students who study intensely or learn a new skill tend to have more REM sleep afterward and sometimes even dream about what they've been studying. So yes, technically cramming in your sleep is real, though your dream self might confuse calculus with cartoon animals. Emotional processing. Another possibility is that dreams help us process emotions. During REM sleep, emotional centers like the amygdala light up while stress-related chemicals simmer down. This combination allows your mind to revisit emotionally charged memories without the full weight of panic or fear. It's like having a therapist in your head who's willing to role-play your awkward interactions but with more surreal scenery. That dream where you were calmly arguing with your ex on top of a slow-moving elephant, that might have been your brain's way of saying, "Hey, I'm working through it." The threat simulator. There's also the idea that dreams are a kind of threat simulator. According to this theory, dreaming is our evolutionary brain's way of preparing for real-life dangers by running through imaginary scenarios, being chased, lost, attacked, or late for a test you didn't study for in a class you never attended. Your brain practices how it might respond to high-stakes situations. It's rehearsal, essentially, slightly unhinged, wildly exaggerated rehearsal. People who grow up in more dangerous environments often have more frequent, vivid dreams, as if their minds stay on high alert even during sleep. The activation synthesis hypothesis. Not all theories are emotional or evolutionary. One mechanical explanation is the activation synthesis hypothesis. This view holds that dreams are basically the result of random electrical impulses in the brainstem during REM sleep. These impulses trigger images, memories, and feelings, and your cerebral cortex, the brain's storyteller-in-chief, tries to piece it all together into something coherent. It doesn't always succeed, hence the talking ducks and the sudden appearance of your third-grade teacher on a pirate ship. Dreams, in this view, aren't purposeful narratives. They're your brain making the best of a very strange and spontaneous situation. Cognitive development. There's also the theory that dreaming helps with cognitive development, particularly in children. Kids dream a lot more than adults, and their dreams are often more imaginative and bizarre. talking animals, magical powers, flying, transforming, building strange new worlds. Some researchers believe this imaginative dream activity helps the developing brain stretch its problem-solving muscles and emotional awareness. So when your child tells you they fought a dragon made of spaghetti to rescue a cloud, they're not just being silly. They're growing new pathways in their mind. Creativity and problem solving, even for adults. Dreaming may play a role in creativity and problem solving. Have you ever gone to bed, stuck on a problem, and woken up with a sudden, elegant solution? That's not magic. That's your brain quietly working the night shift, free from distractions and logic. Famous examples include Paul McCartney dreaming the melody to Yesterday, and the chemist August Kekulé dreaming of a snake biting its own tail, leading him to the structure of the benzene molecule. Dreams let the mind wander down paths it might never consider when fully awake. They free us from rules, and sometimes that freedom leads to insight. Multiple functions despite all these theories: emotional processing, memory sorting, threat rehearsal, dream synthesis, problem solving. No single explanation has won the day. It's very likely that dreaming serves multiple purposes all at once, like a late-night variety show where your brain juggles cleaning house, solving puzzles, rehearsing survival scenarios, and throwing in the occasional musical number just for fun. That's the strange beauty of dreaming. It's not tidy, it's not always rational, but it's undeniably human. Every night, your brain spins stories for an audience of one, stories you rarely remember but that somehow shape your emotions, memories, and maybe even your imagination. The brain regions behind dreams. What part of your brain is responsible for that dream, where you were trying to take an exam in a swimming pool filled with marshmallows? The answer lies not in just one part of the brain, but in a delicate nocturnal dance among several regions, each with its own role in the theater of the dreaming mind. The prefrontal cortex, the editor, takes a nap by day. The prefrontal cortex is the responsible adult in the room, the logical thinker, the planner, the internal voice that says, maybe don't send that email in all caps. It's heavily involved in decision-making, rational thought, and impulse control. But when you fall asleep, especially during REM sleep, this part of your brain takes a little nap of its own. It quiets down, steps aside, and lets the rest of the brain take the stage. The result? Dreams that are illogical, boundary-pushing, and often completely bonkers. Without the prefrontal cortex overseeing things, the brain is free to combine ideas and images in the most unfiltered, uninhibited way possible. It's like your inner editor has left the room, and now the art department is running wild. The amygdala. Emotional intensity. Meanwhile, the amygdala becomes particularly active during REM sleep. This almond-shaped region deep in the brain is responsible for processing emotions, especially fear, anger, and pleasure. When you find yourself trapped in a dream where you're being chased through an airport by someone dressed as your childhood pet, you can thank your amygdala for dialing up the emotional intensity. It's the part that makes dreams feel important, even when the plot makes zero sense. Because your brain's stress response systems are dialed down during REM, you can re-experience intense emotions in a relatively low-stakes environment. You might feel afraid or thrilled in a dream, but without the heart-racing panic of real danger. The hippocampus, the hippocampus, your brain's librarian, is responsible for creating and organizing memories. It's closely linked with dreaming, especially when dreams incorporate real places or familiar faces. The hippocampus helps retrieve the raw materials your dreams use: the restaurant you passed earlier, the song stuck in your head, your second-grade teacher who inexplicably reappears as a karate champion. But the hippocampus isn't fully online during REM sleep, which may be why dream memories tend to be disjointed and hard to recall. You might remember the mood of the dream or a particular image, but often the details slip away the moment you wake up. The filing cabinet is open, but the lights are dim. The occipital lobe, the film studio, the occipital lobe, located at the back of the brain, is your primary visual processing center. During REM sleep, it shows significant activity, which makes perfect sense given how visual dreams often are. Even people who are born blind report vivid sensory dreams, often focusing on sound, touch, and spatial awareness. For the rest of us, dreams are like mini movies, full of shifting landscapes, strange lighting, and unexpected camera angles. It's your brain's very own film studio, operating entirely without eyes. PGO waves, the opening act. Then we have PGO waves, short for ponto-geniculo-occipital waves. These bursts of neural activity originate in the pons, part of the brainstem, then move through the lateral geniculate nucleus, involved in visual processing, and finally reach the occipital cortex. It's believed that PGO waves play a key role in initiating REM sleep, and perhaps even in the formation of dream imagery. Some researchers think of them as the opening act of the dream sequence, like someone dimming the lights and drawing the curtain back before the performance begins. REM atonia. The safety feature. One of the most fascinating things about dreaming is how the brain manages to become both highly active and strangely disconnected at the same time. Your motor cortex, the part that controls movement, your dream self can run, dance, fly, or flail wildly. But your body doesn't actually move because another part of your brainstem is doing something very helpful, temporarily paralyzing your muscles. This phenomenon is called rematonia, and it's what keeps you from acting out your dreams in real life. It's like the brain puts a little do not disturb sign on your muscles while your dream self explores a world that defies the laws of physics. There are rare cases where this muscle paralysis doesn't function correctly, a condition called REM sleep behavior disorder. People with this condition might physically act out their dreams, sometimes leading to injury. It's a reminder of how precise the orchestration needs to be to keep the show running smoothly without causing chaos in the real world. Lucid dreaming, waking up inside the dream. Imagine you're dreaming. You're walking through a vast library made entirely of marshmallows. The librarian is a talking raccoon in spectacles. Everything feels real. Then suddenly, a quiet thought drifts through your mind. Wait a minute. This is a dream. And just like that, the whole dream shifts. You're aware. You're lucid. What is lucid dreaming? Lucid dreaming is one of the most fascinating quirks of human consciousness. It's that moment in a dream when you realize you're dreaming, and sometimes you can even control what happens next. You might choose to fly, speak to a long-lost friend, or more realistically, spend the entire dream trying to walk through a wall while getting distracted by the carpet. Scientists define lucid dreaming as a hybrid state of consciousness, a blend of waking awareness and REM sleep. In this state, the dreamer maintains metacognition, self-awareness, while the brain remains immersed in REM-generated imagery. In simpler terms, your brain is asleep, but a part of you has woken up just enough to realize this is all in my head. The brain science. What's going on in the brain when this happens? Normally, during REM sleep, the prefrontal cortex is mostly offline. That's why dreams are often bizarre and illogical. But in lucid dreams, researchers have observed reactivation in certain areas of the prefrontal cortex, particularly the dorsolateral prefrontal cortex, which is associated with self-awareness and reflection. Brain scans of lucid dreamers show a unique neural signature, a combination of REM sleep brain activity and the kind of coherence you'd normally see when someone is awake and thinking critically. It's like your mind opens one eye and quietly says, "Ah." Communicating from dreams, some lucid dreamers can even signal to researchers from within a dream. In sleep labs, participants trained in lucid dreaming have been able to perform agreed-upon eye movements while dreaming, such as looking left, right, left, which can be detected by external monitoring. This might sound like science fiction, but it's real. Dreamers in their beds, eyes closed, bodies still, sending subtle Morse code signals from inside their dreams. It's as close as we've come to real-time communication with the dreaming mind. Learning to lucid dream. Some people stumble into lucid dreams accidentally. They might be in the middle of a particularly strange dream and suddenly think, this can't be real, and boom, lucidity dawns. But others actively train themselves. Popular techniques include MILD, mnemonic induction of lucid dreams. This involves waking up after about 5 hours of sleep, focusing on the intention to realize you're dreaming, and repeating a phrase like, next time I'm dreaming, I will remember I'm dreaming, as you drift back to sleep. WILD, wake-initiated lucid dreaming. This is more advanced. The goal is to stay mentally aware while your body falls asleep. If done successfully, you can transition directly from wakefulness into a lucid dream, almost like walking into a different room in your mind. Reality checks. This involves questioning your environment throughout the day. Am I dreaming? By doing this habitually, you increase the chances that you'll ask the same question while dreaming and realize the answer. Some people try to push a finger through their palm or look at a clock twice to see if it changes. The appeal and uses for some. Lucid dreaming is simply fun, a chance to explore fantastical worlds, fly, or visit impossible places. For others, it's therapeutic. People who suffer from chronic nightmares, especially those linked to PTSD, have used lucid dreaming to confront and alter their dreams. Imagine being able to turn and face the monster in your recurring nightmare and say, "You're not real, and this is my dream." For some, that moment of control can be deeply healing. Lucid dreaming is also a playground for creativity. Artists, writers, musicians, and even scientists have explored ideas within lucid dreams. Salvador Dali famously used dream interruption to mine his subconscious for surreal imagery. Caveats. Despite the excitement, lucid dreaming isn't something everyone experiences easily. Some people can learn it with practice, while others may go their whole lives without ever realizing they're dreaming. And because lucid dreaming exists at the crossroads between sleep and waking, too much deliberate practice, especially techniques that interrupt sleep cycles, can reduce sleep quality. It's all about balance. Nightmares and night terrors, not all dreams are made of marshmallows and whimsy. Sometimes your sleeping mind turns the lights down, turns the volume up, and delivers something far less comforting. A nightmare. What are nightmares? Nightmares are the emotional thunderstorms of our dream life. They jolt us awake, leave our hearts racing, and often stick around like fog long after morning comes. A nightmare is a vivid, disturbing dream that typically occurs during REM sleep. The big difference from regular dreams is emotional tone. While your usual REM dream might be bizarre or confusing, a nightmare ramps up the intensity, often triggering fear, anxiety, sadness, or shame. Most people experience nightmares from time to time, and they're perfectly normal. But when nightmares become frequent or recurring, they can start interfering with sleep quality and emotional well-being. This is known as nightmare disorder, and it's more common than you might think, especially in people with high stress, anxiety, or trauma histories. Why we have nightmares? There's a strong link between nightmares and real-life emotional experiences. Some researchers believe nightmares serve a similar purpose to regular dreams, helping the brain process difficult emotions, but they do so with high-voltage intensity. Think of it like your mind running simulations of worst-case scenarios, trying to prepare you emotionally for danger or distress. In this sense, nightmares might actually be protective, a psychological fire drill. For people recovering from trauma, nightmares often replay the event itself, whether literally or symbolically. This is especially true for those with PTSD. Nightmares can become stuck loops, forcing the dreamer to relive painful moments night after night. This is where treatments like imagery rehearsal therapy come in. It's a technique that involves mentally rewriting the nightmare during waking hours, changing the story to something less frightening, and rehearsing the new version repeatedly. Over time, this can reduce the frequency and intensity of nightmares. It's a way of telling your brain, we've learned what we needed to. You can let this go now. Night terrors, a different beast. Night terrors, also called sleep terrors, are different from nightmares. They usually occur during non-REM deep sleep, particularly in the early part of the night. Unlike nightmares, which are vivid and dreamlike, night terrors are more like sudden panic storms erupting from the brainstem. During a night terror, a person might sit bolt upright, scream, thrash, sweat, or appear wide-eyed with fear, but they're not fully awake. Their eyes might be open, but they're unreachable. Often, they'll have no memory of the event the next morning. Night terrors are much more common in children than adults, and most kids eventually outgrow them. They're generally harmless and not linked to long-term psychological issues. In adults, they're rarer but can be associated with sleep disorders, stress, or certain medications. They're not technically dreams at all, more like a misfire between sleep states where the brain gets stuck halfway between deep sleep and wakefulness. Sleep paralysis, the waking nightmare. Then there's sleep paralysis, the eerie cousin of nightmares and night terrors. It happens when your mind wakes up before your body does. You're conscious, but you can't move. Often this state is accompanied by hallucinations, shadows in the room, pressure on the chest, strange sounds. Historically, these episodes were blamed on demons, witches, or malevolent spirits. Today, we know it's a natural glitch in the REM sleep system, where the muscle paralysis meant to protect you during dreams lingers too long after waking. Despite the terrifying sensation, sleep paralysis is harmless and usually passes within seconds or minutes. Why the brain scares itself? One theory is that negative emotions are simply more memorable, and evolution has a stake in remembering potential dangers. You're far more likely to remember a dream about escaping a forest fire than one about eating a nice sandwich. The emotional charge helps cement the dream in memory and makes you more likely to learn from it. From a survival perspective, fear is a powerful teacher. The good news is that most people don't have nightmares every night. They're occasional visitors, intense, yes, but usually fleeting. And for those who do experience them more often, there are tools to help, from sleep hygiene and stress management to therapy and targeted dream techniques. Dreams and mental health. Dreams and mental health are closely linked, like two dancers moving through the night, each influencing the other in subtle, unexpected ways. Dreams as emotional mirrors. When you're stressed, anxious, or emotionally overwhelmed, your dreams tend to get louder, not literally, but louder in content. They become more vivid, more emotional, sometimes more chaotic. You might dream about being chased, lost, unprepared, or frozen in place. These dreams can mirror the emotional turbulence in your waking life. People with depression often report more negative dream content. Their dreams may feel heavy, repetitive, or emotionally flat, mirroring the numbness or sadness they experience while awake. Anxiety disorders tend to show up as dreams filled with threat, pressure, or social embarrassment, but the connection runs deeper than content. The structure of dreams, how fragmented or coherent they are, can also shift with mental health. People going through intense stress or psychological trauma often experience more fragmented, jarring dreams. It's as if the brain is trying to process too much too quickly without enough glue to hold the pieces together. PTSD and dreams. This is particularly true in post-traumatic stress disorder, PTSD. Nightmares are one of the hallmark symptoms. These aren't just bad dreams, they're often reliving the traumatic event itself over and over. While REM sleep is usually a helpful adaptive space for emotional processing, in PTSD, that system seems to break down. Instead of soothing the wound, the dream repeats it like a stuck record. Interestingly, not all REM is equal. In healthy individuals, REM sleep tends to reduce the emotional sting of difficult memories. You can still recall the event, but it no longer carries the same emotional voltage. But in people with trauma, that desensitization process doesn't work properly. Medications and dreams can also be shaped by the tools we use to manage mental health. Many antidepressants that affect serotonin and norepinephrine also affect sleep. Some suppress REM sleep altogether, leading to fewer remembered dreams. Others cause REM rebound when the dosage is adjusted, meaning you might suddenly experience very vivid, emotionally intense dreams. Dreams as windows. There's also growing interest in using dreams as a window into mental health. While we're still far from using dreams as diagnostic tools, researchers are exploring how dream content might help detect shifts in emotional well-being. What's clear is that dreams are deeply personal. They can reveal emotional truths we haven't said out loud. They can reflect our hopes, fears, and the tangled middle ground where those two live side by side. And sometimes, when the world feels overwhelming, dreams can offer symbolic relief, giving shape to things we haven't yet found words for. There's even evidence that dreams might be helpful in problem solving and emotional growth. In therapy, clients will sometimes dream about difficult decisions or unresolved feelings. While the dream doesn't hand them a perfectly wrapped answer, it often nudges them closer to clarity. It's the brain's way of quietly saying, "You're working on this, even if you don't realize it." Do animals dream? You've probably seen it. A dog sleeping soundly, paws twitching, tail flicking, maybe even letting out a muffled bark. Or a cat stretched out, whiskers twitching, legs paddling as if chasing something. And if you've ever wondered whether animals dream, the answer is probably yes. The evidence: almost all mammals and many birds experience REM sleep, the same phase in which humans do most of their dreaming. In animals, this looks familiar: twitching, flickering eyes, occasional sleep barks or meows. But brain scans offer even stronger evidence. In a famous MIT study, researchers trained rats to run through a maze while recording their brain activity. Specific patterns of neurons would fire as the rats moved through the maze. Later, while the rats slept, researchers observed those exact same neural patterns replaying during REM sleep. It was as if the rats were dreaming about the maze, running it again in their minds. Birds, too, show signs of dreaming. Zebra finches have been studied for their complex singing behavior. When they sleep, their brains replay the neural patterns used in singing, almost as if they're rehearsing their songs while unconscious. Dream karaoke, if you will. Recent studies suggest that even reptiles might have dreamlike sleep. Certain species of lizards exhibit sleep cycles resembling both M and non-REM sleep. It raises a fascinating possibility. Dreaming might be a much older evolutionary trait than we once believed. What are they dreaming about? While we can observe neural patterns and behaviors, we can't ask a cat, "Did you dream about hunting?" But we can make reasonable guesses. Animals probably dream about things that matter to them: navigating their territory, social bonding, hunting, playing, eating. The content may not be symbolic or metaphorical like human dreams sometimes are, no existential angst, but they're likely grounded in experience. In this way, dreaming might serve similar functions across species: memory consolidation, emotional regulation, and behavioral rehearsal. Can animals have nightmares? There's even evidence that animals can experience nightmares. Lab rats exposed to stress show different patterns of REM sleep, sometimes fragmented, sometimes more intense. This suggests that, like us, animals use dreams to process difficult or frightening experiences. Our pets. What about our pets? Researchers believe that dogs in particular have vivid dreams. Smaller dogs tend to enter REM sleep more frequently, while larger breeds may stay in REM longer. And while we can't know the content, it's very likely that your dog dreams about you because you're such a central part of their life. Cats are a bit more mysterious, but they dream too. Studies on cats in the 1960s helped scientists first understand the connection between REM sleep and dreaming. When researchers temporarily disabled the part of the brain that causes REM paralysis, cats would act out their dreams, stalking, pouncing, even grooming, all while fast asleep. Philosophical questions dreaming in animals raises fascinating questions. If a rat dreams, does it have a sense of self in that dream? Do animals distinguish between the real and the imagined? Maybe dreaming is one of those universal brain languages, a way for all creatures, great and small, to replay, remember, and reflect. Maybe it's not uniquely human after all, but something woven deep into the fabric of life itself. A nighttime world where instinct and memory, the future dream recording and beyond. For most of human history, dreams have been private, a world seen by one person alone, fleeting, mysterious, and often forgotten by morning. But now scientists are picking at the lock. Decoding dreams, researchers have long used EEG to monitor brain waves during sleep. But EEG doesn't tell you what someone is dreaming about. For that, you need fMRI, functional magnetic resonance imaging, which lets scientists see which parts of the brain are active and when. One of the most fascinating experiments happened in Japan at the ATR Computational Neuroscience Laboratories. Researchers asked participants to fall asleep in an fMRI machine, the least relaxing sleep environment on Earth. Before the experiment, participants had been shown hundreds of images while awake, and their brain activity was recorded. Each image created a neural fingerprint. Then, during sleep, when similar patterns showed up, researchers could compare them to the waking data. And it worked. With about 60% accuracy, the team could guess what kind of image the person was dreaming about, whether it involved a person, a book, a car, or a tree. They couldn't describe the dream's plot or emotions, but they could identify what was being visualized. It was the first real peek behind the curtain of a sleeping mind. Ethical questions. This raises big ethical questions. Dreams are private by nature. They're one of the last unfiltered expressions of the self, a space where no one else can follow. So if the day comes when we can record or decode dreams with precision, what happens to that privacy? As neurotechnology advances, ethicists and lawmakers are already discussing the need for neuro rights, basic protections for mental privacy, freedom of thought, and the sanctity of the self. Therapeutic potential. Imagine people with communication disorders who can't speak, write, or express themselves outwardly. If we could one day translate their dreams into language or images, we might gain access to their inner worlds in ways never before possible. Or consider the therapeutic potential if a psychologist could see patterns in someone's dreams over time. Recurring symbols, emotional arcs, unresolved tensions, it might offer a new tool for understanding mental health. Targeted dream incubation. There's also something called targeted dream incubation. This involves playing specific sounds or words during sleep to gently guide dream content. For example, if someone is learning a new language, they might hear vocabulary in their sleep to reinforce memory. Or if they want to dream about flying, they might hear ambient wind sounds or soft cues about the sky. It's not full-blown dream control, but it's a gentle nudge in a chosen direction. Experiments have already shown that playing specific sounds or words during certain stages of sleep can trigger related dream imagery. Imagine combining that with wearable sleep tech, headbands that monitor your brain waves, or earbuds that deliver cues only during REM. You could one day guide your dreams to help solve problems, rehearse speeches, or gently work through emotional blocks. Dream sharing. And what about dream sharing? It's one of the oldest fantasies we have. The idea that two people could experience the same dream, or that we could record and play back a dream like a movie. We're nowhere near that yet. But researchers are starting to decode visual dream content using fMRI and machine learning. In the future, it's possible we'll be able to turn dream fragments into rough images, maybe even animations. You could watch a version of your own dream the next morning, or share a surreal dream memory with a friend, not because it's perfectly accurate, but because it captures something of the tone, the mood, the magic. Lucid dreaming could have a renaissance too, not as an escape, but as a tool for emotional growth, creativity, even learning. Some researchers are exploring how lucid dreamers can practice real life skills in their dreams. The brain doesn't fully distinguish between imagined action and physical rehearsal. If your dream self practices kindness, courage, or compassion, perhaps your waking self benefits too. AI and dreams is. Then there's AI. Artificial intelligence is being trained not just to analyze brain activity, but to recognize patterns, suggest dream themes, and even build interactive environments that mimic the feel of dreams. Some virtual reality developers are experimenting with dream inspired environments that respond to emotion, spaces that feel less like games and more like lucid dreams you can explore while awake. The heart of it, but for all this dazzling technology, there's something quietly reassuring to remember. Dreaming at its core doesn't require gadgets. Your brain already has everything it needs to dream, to remember, to process, to create, to wander. All you need is sleep and perhaps a little curiosity. The future of dream science may bring new tools, new therapies, and new ways to connect, but it will never fully replace the simple wonder of waking up with a strange image in your head, blinking in the early light. Where did that come from? No matter how far science takes us, dreams will always retain a little mystery, a little poetry, a space where the brain stretches out, curls into itself, and drifts somewhere only it knows how to go. The poetry of the sleeping mind. And so here we are, gently gliding back from the strange, beautiful world of dreams. We've tiptoed through REM cycles, wandered the halls of memory, listened to the whispering amygdala, watched rats replay their maze-running dreams, and even peeked into the future of dream science. We've seen that dreams aren't just nighttime noise or random neural static. They're stories your brain tells itself, sometimes clumsy, sometimes profound, always intimate. They're the mind's way of processing, practicing, problem solving, and perhaps most importantly, remaining fluid and flexible even in the absence of external input. What we know so far is astonishing. We know that dreams emerge from a precisely orchestrated symphony of brain regions. We know that the prefrontal cortex takes a nap while the amygdala turns up the emotional volume. We know that your hippocampus sorts through the day's memories like a librarian on the night shift, deciding what stays and what goes. We know that your body becomes temporarily paralyzed to keep you safe from your own imagination. We know that dreams likely serve multiple purposes: consolidating memories, processing emotions, rehearsing for potential threats, solving problems creatively, and maintaining the plasticity of the neural networks that make us who we are. We know that almost every creature with a complex nervous system dreams in some form, suggesting that dreaming is not a luxury, but a fundamental feature of consciousness itself. We know that you can learn to become aware within your dreams, to shape them, to use them as a space for exploration and healing. We know that nightmares, while distressing, are often your brain's way of working through difficult emotions and experiences. We know that the content of your dreams reflects your waking life, while simultaneously transforming it into something entirely new. We even know that science is beginning to decode dreams, to translate neural patterns into rough images, to guide dream content with subtle cues, and to use dreams as windows into mental health and cognition. But what we don't know, may be even more wondrous. We don't know exactly why evolution preserved this vulnerable state where we lie unconscious for hours, creating elaborate internal experiences that we mostly forget. We don't know why some dreams feel prophetic or deeply meaningful while others are pure absurdity. We don't know if there's a limit to how much we can control or shape our dreams, or what the long-term consequences of such control might be. We don't fully understand the relationship between dreams and creativity, between dreams and insight, between dreams and the development of the self. We don't know if animals experience their dreams the way we experience ours, with that sense of being immersed in another reality. We don't know if consciousness itself is somehow related to the capacity to dream. Because for all the brain scans and neural maps, dreams still slip through the cracks of complete explanation. They remain, in many ways, the mind's poetry, part science, part soul, part mystery that may forever elude full comprehension. And perhaps that's as it should be. Because there's something sacred about the private theater of dreams. In a world where almost everything is observed, recorded, and shared, dreams remain one of the last truly private spaces. They're yours and yours alone, unless you choose to share them. They're unfiltered, uncensored expressions of your mind at its most creative and uninhibited. Dreams remind us that we are not purely rational beings. We are not computers processing information in neat, logical sequences. We are complex, emotional, imaginative creatures whose minds continue to create and explore even when we're not consciously directing them. Dreams are proof that there's more going on inside us than we can ever fully access or understand. They're also deeply democratic. Everyone dreams regardless of age, culture, education, or socioeconomic status. The CEO and the janitor, the scientist and the artist, the child and the elder, all of us spend our nights in roughly the same state, creating private worlds from the raw materials of our neural activity. In dreams, we're all equal travelers in the landscape of the unconscious. So as you drift off tonight, whether your brain takes you on an epic adventure, a quiet memory, a problem-solving session, or something so bizarre it defies all logic, let it. You don't need to understand every detail. You don't need to interpret every symbol or analyze every plot twist. You just need to let go and trust that your brain knows what it's doing, because it does. Your brain has been perfecting the art of dreaming for as long as there have been brains complex enough to dream. It knows how to sort through memories, how to process emotions, how to rehearse for challenges, how to maintain its own plasticity and health. It knows how to create beauty and meaning from chaos, how to solve problems you didn't even know you were working on, how to keep you sane and functional in a complicated world. All you have to do is sleep. And if this video has made you just a little too fascinated to fall asleep, well, I apologize, but at least you might have learned something along the way. You've learned that sleep is not passive but active, that dreams are not meaningless but multifunctional, that your brain is not resting but renovating. You've learned that you share this experience with every mammal, every bird, perhaps every complex living thing on Earth. You've learned that science is beginning to decode the language of dreams while respecting the mystery at their heart. A fair trade, I hope. Before we part ways, if you enjoyed this slow journey through the sleeping brain, I'd be truly grateful if you gave the video a gentle thumbs up, subscribed to The Sleepy Scientist, or left a comment below. Where are you listening from tonight, and what time is it in your corner of the world? Are you preparing for sleep, or are you one of those fascinating night owls who finds calm in the dark hours? I'd love to know where this little cloud of calm has drifted. And if you're struggling with sleep, if your dreams have been troubled lately, if you're one of those people who rarely remembers their dreams and wishes you could, please be gentle with yourself. Sleep and dreams are influenced by so many factors: stress, health, environment, habits. There's no one right way to sleep or dream. Your experience is valid, and there are resources and techniques that can help if you need them. Until next time, sleep well, dream freely, and remember, Your mind is still writing stories even in the dark. Stories that only you will see, that only you will experience, that are uniquely, unmistakably yours. Stories that might fade by morning, but that serve their purpose in the deep hours of the night. You are a dreamer. You always have been, and tonight you'll prove it again. Good night.